Okay, morning guys. So I'm going to do question 9 today from your homework last night. I'm also going to do question 10, maybe part 3. I didn't get anyone ask me to do any specific questions today. So they're the questions that I hope to do in the review, and then we will take a very quick look at some of the introductory circle questions as well, okay? So, yep, let's get to it, I suppose. ABCD is a parallelogram, so this is going to be question 9. ABCD is a parallelogram as shown. Calculate the area of the parallelogram. Okay, well that's straightforward enough. We now know that the area of a parallelogram is A by H is equal to area. And so that's going to be 14 times 5, area, which is a half of 140, which is 70. Yep. So that's the, that's the area of that parallelogram. Quite a straightforward question, really. And work out the perpendicular distance from A to DC. From A to DC. Oh yeah, okay. So we have to imagine there's a line going across like this. Okay, and we're looking for, and that's going to be perpendicular, and we're looking for that distance then, okay? So that distance is the same as that distance down here. It's effectively the perpendicular height going from the other base, okay? So therefore 70 should equal the base we're talking about this time, which is 8, multiplied by the perpendicular height, which is going to be the distance, the perpendicular distance from A to DC. So that's going to be by H. So H is equal to 70 divided by 8. H will equal 8.75. So yeah, I never do this in class, but I've changed sides here. Yeah, sorry about this. We would normally go 70 is equal to 8h, and then h by itself is equal to 70 over 8. H is equal to 8.75. Yeah, this is kind of the way that yeah, that's kind of the more conventional way, but this still gets us our correct answer without the need for a sign change or anything like that. Okay, so that's question 9 dealt with. Let's take a look at question 10, part 3 now. And we're given this sort of a shape here. It'd be interesting to see if they call this a trapezium. They do. So because they call it a trapezium, I think we can say that this side here is parallel to that side there. And we're told that the distance between these two is 7. We're told that this base here is 12 and this base here is 4. And we are asked to calculate the area of each of these trapeziums. No, work out the area of each of these trapeziums. Okay, so let's work out the area of that shape there. Right. What I'm going to do is, there's a number of ways we can tackle this. I'm going to imagine that we complete the parallelogram. So I'm drawing in some imaginary lines there. Now, that red distance there, that must be 8. Because in a parallelogram, the opposite sides are equal. So the overall area of that new parallelogram is 7 times 12, which is equal to 84. So let's call that big area. Now, let's shade this in so we can talk about it. So now red area is equal to 8 by 7 by a half. So that's a half the base by the perpendicular height, which is 7. So that immediately gives us 28. So therefore, the green area, that area there, will be the area of the big shape if we subtract the red area from it. So it's going to be 84 minus 28, which gives us, it will give us a 6 anyway, will it? And then we have to pay back one, so that gives us a 5. So the area of the green is 56. I just want to check that at the back of the book, just to make sure we're okay with that. So this was exercises 9.1. And this is question 10, and the answer is 56. Yeah. Okay, so that was quite nice. So I want to start looking at the questions on the circle, and these start on page 240. Okay, so I'm going to do question 4 now. So on the old book, if you're in 6th year or if you're in 5th year and using the old book, the page is 242. I'll put it in Teams what the pages we're dealing with are, if we're dealing with the new book if you're in 5th year. Okay, so find the length of the arc AB in each of the following sectors shown below. Give each answer in centimeters correct to one decimal place. So they give us, we're going to take a look at part 2. And they give us a kind of a shape like that, like a pizza slice. And they tell us that it's 30 degrees in there. Now, these questions are really, really nice because they work on the basis that we have to think that the circle is actually a whole circle. Okay, so we imagine that there's a full circle and we will deal with the fraction of that circle when we come across it. Okay, so find the length of the arc AB. So we're asked to find the length of this thing here. Yeah, a portion of a circle is called an arc. So that green part there, that's an arc. So if I just draw a curve like that, that is an arc, okay? If it's part of a circle, it's called an arc. Now, we're told that that distance is 12 as well. Okay. So, how does this work? Well, I'm going to imagine that the question was first of all asked me to find the full length of this circle all around here. So we know that the full length of this circle all around here is 2 pi by r. So L is equal to 2 pi r. In our case, that's 2 times pi times 12, which is our radius. So that's equal to 24 pi, which is equal to 24 pi, 75.398 something, okay? So that is if we were talking about the full circumference of our circle. But we're not talking about the full circumference, we're just talking about a portion of it. So we are going to find out what portion of our full circle we're dealing with. Now if we go back over to our picture, if I was to rotate this the full way around, I would go through 360 degrees. Okay, but I've only gone 30 degrees. So the fraction of the full circle I've gone is 30 over 360. So we want that fraction of the full amount. So we multiply that by the full amount, which was 75.4, let's say, and that's equal to 6.283 or something like that. It's actually 2 pi. Weird. Okay, so I did some rounding here, and I didn't round it in my calculator, so that's why it looks like that. So it's probably equal to 6.3. Yeah, so that is that's the so that's what we do. Okay, we work out the full amount, and we work out what fraction of the full amount we have, and we work out that fraction of the full amount. And the same will be for area. So if we wanted to find the area of that, now this wasn't asked in the question. Okay, it wasn't asked in the question, but let's imagine we were asked to find the area of that shape, of that pizza slice. So we know that we call this curve here the arc. We call that the radius, and our radius is 12. Now, again, we want to find the area here. So we're looking for this area in here. So the area of the full shape, what's our formula for the area of a full circle? Very good. So area is equal to pi r squared. So our area is pi by 12 squared, which is equal to 144 pi, which is equal to 452.39, let's say. Now this is this thing we were talking about the last time. Okay, we're not interested in the area of the full circle. We want to know, we want to know the area of this sector. Okay, so this pizza slice here, its technical name is a sector. The technical name for this curve is an arc. So the area of that arc is 30 over 360. So it's that fraction of a full circle multiplied by the area of the full circle. So it's that fraction of the full amount, which is equal to, multiplied by 30 over 360, which is equal to 37.7, let's say. So it's 37.7, and that's going to be centimeters squared this time. Yep, so that's how we would tackle those questions when it comes to arcs and sectors. Now, you might have heard me in that question talking about the area of a circle. And I want to apologize for that, because this thing here is a circle. And we know, because we've studied coordinate geometry of a circle, that a circle refers to these points all around the circle, right? Yeah, that's what the circle is. It's a collection of these points that are all equidistant from a center point called the center. So really, when we talk about the area of a circle, it's meaningless, because we're talking about the area of this line, this curvy line, and that has no area. So the phrase I should have said was, we find the area of the disk. So the disk refers to the space contained by this circle. So it's a technical point, but yeah, it's probably better that we use the correct words, okay? So this space here, that space, that's a disk, right? So our technical words we have are disk, circle is the line that contains, the circle is contained, sorry, the disc is contained by the circle. Similarly, this line out here, we call that the arc, and the space within here is called the sector. So you have sectors, arcs, circles, and then discs would be the space within inside a circle. Okay, so I'll put questions up for you to do on Teams as well.